Hi everyone! In this video we're going to talk more about reflections. So let's, just like the last video, let's first give a definition for a reflection. If you remember in the introduction to transformations, a reflection was sort of like creating a mirror image. So one way to say that is each point moves to the opposite side of a line. You can think of the line as being sort of like the mirror, so if one point is this far away from the mirror, you see it perpendicularly across the same distance away on the other side of the mirror. So maybe we can be even more specific. Each point moves to the opposite of a line perpendicularly. So let's look at examples. In the cases that we'll be looking at, we're only interested in reflections across the y-axis and across the x-axis. So across the y-axis, you'd have something on one side, and then it would flip to the other. Across the x-axis, you'd have something above, and then it would flip to being below. So first, let's do reflections over the y-axis. Actually, let's do reflections over the x-axis first. That's a little bit easier. So the red graph is one of our parent functions, except it's shifted up by 1. So it's the absolute value function, absolute value of x plus 1, shifted up by 1. The blue graph is a reflection over the x-axis. So let's look at the tables so that we can see some of the points on these graphs. So if we look at our focal point, it's at 0, 1 on the red graph. On the blue graph, it's at 0, -1. When we look at the value when x equals 1, we have 1, 2. When we plug in 1 to the absolute value function plus 1, we get 1 plus 2. Or 1 plus 1, which is 2. 1 plus 1. Okay. Now if we plug in 1 into the blue function, we get -2. We're down here. So in the red function, if we plug in 2, we get 3. On the blue function, what do you expect the y value to be? The -3. So it's very clear that what we're doing is we're taking the original function and we're just taking the negative of it in order to get the blue graph. So let's go back to our sheet of rules and write that down as a rule. So to get a reflection over the x-axis, all we have to do is take the negative version of the output that we started with. So let's make a rule. If g of x equals the negative of f of x, then the graph of g of x is a reflection over the x-axis of the graph of f of x. So that's a pretty easy one. We just take all the positive values and make them negative. It makes sense that it should flip over the x-axis that way. What about reflections over the y-axis? So here's the example we're looking at. I have the red graph is sort of like the square root graph, but it's shifted to the right by 1, which means instead of x, we put x minus 1. So we have the square root of x minus 1 is this graph. Now, if we wanted a reflection over the x-axis, I would have to take the negative of that. So let me just do that to show you really quickly what that looks like. Negative of x minus 1 to the 0.5. That gives us a reflection over the x-axis. I just took negative of the whole thing. But if I want to get a reflection over the y-axis, that means that if I'm 1 away on the x-axis, if I'm at 1, 0, then I should be 1 away on the opposite side of the y-axis. So I should be at -1, 0. So one way to think about this is that for the blue graph, in order to get 0, I should plug in the negative of what I plugged in on the red graph. Let's see if that's true again. In order to get 2 on the red graph, I need to plug in 5. So in order to get 2 on the blue graph, I should plug in the negative of that. I should plug in -5. So what I'm saying is that the graph g of x is obtained by using negative x instead of x. So here, my function was x minus 1. Here, instead of x, I put negative x, so my function is negative x minus 1. So we can write that as a rule. If g of x equals f of negative x, it's almost the same as f, except we're plugging in negative x instead of x, then the graph of g of x is a reflection over the y-axis of the graph of f of x. So again, here we change the entire function. We put a minus sign in front of everything. Here we just changed x. When we change the entire function, when we do something sort of on the outside of f of x, it gives us sort of a change in the y values. If we change, which is similar to this. When we just added c to the entire function, we move sort of vertically. When we change the x's, we move horizontally. We flip over the y. Here, when I just changed the x's, I shifted left and right instead of up and down. So if the change happens on the inside of parentheses, we're moving in the x direction. If the change happens on the outside of the function, we're moving in the y direction. Let's do one example to make sure that everything has clicked. We want to know, what does the graph of the absolute value minus x plus 2 look like? So it looks like two transformations have happened here. The parent function is the absolute value of x. But we've switched x to negative x, and we've also added 2 inside of the absolute value. So in order to figure out the order that the transformations happened, we just use order of operations. So this negative, we have to deal with that first, because it's like multiplying negative 1 by x. By changing x to negative x, that's what we did up here. It means that the graph is a reflection over the y-axis. So let's draw first just the graph of absolute value of negative x. So here's the graph of absolute value of x. Now, let's draw in a different color. Oops, I wanted a different color. Here, let's try this. This is the graph of the absolute value of negative x. Oops, that's wrong, isn't it? When I do, this is bad. Let's go back. If I switch to negative x, I'm reflecting this way, right? So this arm goes to this side, and this arm goes to this side. So the graph of absolute value of negative x actually looks the same. Makes sense, right? If you plug in a negative into the absolute value function, that negative doesn't matter because the absolute value just takes the positive part. Okay, so by switching from x to negative x, we got a reflection across the y-axis. That we know from our rules. So what else did we do? We also added 2 onto the whole thing. Well, not onto the whole thing. We added 2 onto the x part. It's still inside. So that is like doing this. So we have a horizontal transformation to the left by 2 units. So let's use even a different color this time. One way to start this is to take the focus point and move to the left by 2 units and draw the new graph. So here we have the absolute value of negative x plus 2. Okay, good luck with the examples, and you've got a couple more videos on transformations if you need some more guidance.